Hello, my dear students. In previous class, we have learned how to expand the determinants. Now, in this class, we will discuss some properties of a determinants. Number one, the value of the determinant remains unchanged if its rows and columns are interchange. Properties number one, the value of the determinant remains unchanged if its rows and columns are interchange. For example, A is a matrix. For example, let delta is equal to 2 minus 3 5 6 0 4 1 5 minus 7. Proof is equal to 2 into 0 into minus 7 0 minus 20 and minus 3 is equal to 6 42 minus 4 and plus 5 into 30 minus 0 is equal to minus 40 plus 30 into minus 46 plus 150 is equal to minus 150 is equal to 8 150 is equal to minus 28. This is equal to minus 28. By now, by interchanging rows and columns, then we get delta 1 after interchanging rows and columns 2 6 1 minus 3 0 5 this equal to 5 4 minus 7 is equal to 2 into expanding by using first row, then we have 2 into 0 minus 20 plus minus 6 21 minus 25 plus 1 into minus 12 minus 0. This is equal to minus 20 minus 6 into minus 4 plus 1 into minus 12. This is equal to minus 40 plus 24 minus 12. 24 minus 52 equal to 28. Hence, we have the value of the determinants remain unchanged if its rows and columns are interchange. Hence verified. Next, properties number 2. Property number 2. If any two rows or columns, if any two rows or columns of a determinant are interchange then sign of the determinant change. Sign of the determinant change. If any two rows or columns are interchanged, then the sign of the determinants are changed. For example, we take an example. Let A equal to delta equal to 2 minus 3 5 2 minus 3 5 6 0 4 and 1 5 minus 7. This equal to minus 28. Now interchanging rows R2 and R3. Now interchanging rows R2 and R3, that is R2 interchange to R3, and delta 1 equal to R1 does not change, 2 minus 3 5, and R2 interchange with R3, then we have 1 5 minus 6 6 0 4. Expanding along first row, then we have 2 into 5 4 are 20 minus 0. Next minus 3 into 1 4 are 4 plus 42 plus 5 into 1 0 minus 30. This equal to 30 plus 3 into 46 minus 150. This equal to 40 plus 18 38 minus 150. This equal to 8 equal to 28. Here delta 1 equal to minus delta 1 equal to minus delta. Therefore, if any two rows or columns of a determinants are interchanged, then the sign of the determinants are changed. Next, property number 3. Property number 3. If any two rows or columns of a determinant are identical, or all corresponding elements are same, are all corresponding elements are same, then the value of determinant is 0. If any two rows or columns of a determinant are identical, or all corresponding elements are same, then the value of the determinant is 0. For example, delta equal to 1 2 3 2 1 5 is equal to 1 2 3, then is equal to, we expanding by using first column, then we have 1 into deleting this and these columns, this row and this column, we have 1 3 the 3 minus 5 to the 10. Next, minus 2 into deleting this row and this column, then we have 2 3 the 6, 2 3 the 6 minus 6. Next, plus 1 into deleting this and this row, then the remaining elements are 2 3 1 5, then we have 10 minus 3. This equal to minus 7 minus 2 into 0 plus 7. This equal to minus 7 plus 0 plus 7. This equal to 0. Here the first row and third row are identical. Here the first row and third row are identical. Therefore, the determinant is equal to 0. Hence proof, if any two rows or columns of a determinant are identical or corresponding elements are same, then the value of the determinant is 0. Next, properties number 4. Properties number 4. If each element of a row or column of a determinant is multiplied by a constant k, then its value gets multiplied by k. If each element of a row or column determinant is multiplied by a constant k, then its value gets multiplied by k. For example, delta is equal to 1 3 5 6. This equal to 6 to 606 minus 15. This equal to minus 9. Therefore, 3 into delta is equal to 3 into minus 9. This equal to minus 15. Now, delta 1 equal to 3 into 1 3 5 6. The element multiplying each elements of first row by 3. Then we have 3 9 5 6 is equal to 6 3 is 18. 6 3 is 18 minus 45. This equal to 40 minus 45 plus 18 minus sorry, delta equal to 1 3 5 6. This equal to 6 minus 15 equal to minus 9. Next, 3 into delta equal to 3 into minus 9. This equal to minus 27, and delta 1 equal to 7 3 27. Therefore, the value of d is equal to the value of this. Therefore, if each elements of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. Next, we will discuss the properties 5. Properties number 5. Properties number 5. If some or all elements of a row, all elements of a row or column of a determinant are expressed as sum of two or more terms, then determinant can be sum of two or more determinants. For example, A1, B1, C1 plus lambda 1, A2 plus lambda 2, B2, C2, A3 plus lambda 3, B3, C3. This equal to A1, A2, A3, A1, A2, A3, B1, B2, B3, C1, C2, C3 plus lambda 1, lambda 2, lambda 3, B1, B2, B3, C1, C2, C3. This is equal to this. Next, we will discuss properties number 6. If 2 is element of any row of any row or column of a determinant, the of corresponding elements of order are the value of determinant remains same, that is the value of determinant same if you apply the operation Ri tends to Ri plus k into Rj, or Ci tends to Ci plus k into Cj. If two is elements of any row or column of a determinant, the equimultiplies of corresponding elements of other row or column are added, then the value of determinant remains same. That is, the value of the determinant remains same if we apply the operation Ri tends to ith row tends to ith plus k into zth row, ith row plus k into zth row, or Ci tends to Ci plus k into Cj. Next, we will discuss some problems from exercise 4.2. Exercise 4.2 related to these properties. Exercise 4.2. Using the property of determinants and without expanding, using the properties of determinant without expanding, prove that question number 1, without expanding by using properties, prove that x a, the first row of the elements are x a, x plus a, the second row the elements are y b, y plus b. The third row of the elements are z, c, z plus c equal to 0. Using properties, prove that this equal to this. Solution. Left hand side equal to x a, x plus a, y b, y plus b, z c, z plus c. If we apply C1, this is called first column C1, this is called second column C2, this is called third column C3, and this is called first row R1, this is called second row denoted by R2, this is called third row denoted by R3. If we apply C3 tends to C3 minus C2, applying, if we applying C3 tends to C3 minus C2, properties using properties number 6, C3 tends to C3 minus C2, then we have the C1 does not change, x, y, z, and C2 does not change, a, b, c, and C3 tends to C3 minus C2, x plus a minus a, C3 minus C3 minus C2, therefore x plus a minus a, this equal to x, and y plus b minus b, this equal to y, and z plus c minus c, this equal to z. We know that from the properties of determinant, if two rows or columns are identical, then the determinants is 0. From the properties, we know that if two rows or columns are identical, the determinant is equal to 0. Here, the first column and third columns are identical. Here x, y, z, the first column, and third columns, the elements are x, y, z. These columns and this column, first columns and third columns are identical. Therefore, the determinant is equal to 0, equal to right hand side, hence proof. Since the C1 and C3 are identical. Next,